Okay, up here you see a couple parallel lines, okay? And this thing right here is called a transversal, okay? Any line that touches two or more lines, intersects two or more lines, is called a transversal, okay? Now, when we hit a transversal, when we take a transversal and cross a couple parallel lines, it makes a whole bunch of angles, okay? Looking at angles 2 and 4. From last chapter, what do we know about angles 2 and 4? From last chapter, what do we know about angles 2 and 4? What do you think, Ainsley? They are congruent. You are correct. 2 and 4 are congruent. Why? Who knows the why they are congruent? What's that little theorem that says that they are congruent? There are certain types of angles. Which types of angles are they, Illy? What do you think? It's from last chapter. And it's one question that people didn't do so well on the test, and so that's why I want to make sure we know it now. They are vertical angles. Yep. 2 and 4 are vertical angles. Do you see any other vertical angles here? Does 1 have a vertical angle? With what, Mia? What? 3. 1 and 3 are vertical angles. So we know 1 is the same size as 3, 2 is the same size as 4. What's 6 the same size as? What's 6 the same size as, Cambry? 7. And 5 is the same size as what? Jordan? 8. Okay. So we know they're all the same size because they're vertical angles. Okay. We learned that last chapter. If you don't know what vertical angles are yet, well, hopefully you know it now. Angles that are opposite, 2 and 4, they're equal to each other. 5 and 8, they're equal to each other. 6 and 7, they're equal to each other. 1 and 3, they're equal to each other. Okay? Now we're going to start figuring out what parallel lines have to do with equal angles. Okay? Besides angle 4, what other angles does it look like angle 2 looks to be congruent to, Micah? 5 and 8. Okay? 5 and 8. Now, there's a relationship here. 2 and 5 have a special relationship called corresponding angles. They're called corresponding angles because they're in the same corresponding position. Okay? They're in the same corresponding position. So from this intersection point, 2 is to the upper right, and 5 is to the upper right. So if they're in the same corresponding position and the lines are parallel, lines have to be parallel or this doesn't work. If we have parallel lines and we have angles in the same corresponding position with the transversal, then they're going to be congruent. We have other sets of corresponding angles besides 2 and 5. 1 is corresponding to what angle, Caitlin? 1 and 6 are corresponding angles. 4 is corresponding to what, Mr. Chase? 4 is corresponding to 8, and Braden, what is 3 corresponding to? 7. So that's corresponding angles. Corresponding angles are congruent. Now, angle 4 here. It has a relationship with angle 5. 4 and 5 have a relationship to each other. Now, are 4 and 5 equal or not equal, Isaiah? They're equal, okay? They're both acute angles. They look to be equal, okay? They're on the opposite side of the transversal because 4 is to the left side of the transversal, 5 is to the right side of the transversal. And they're to the insides of the parallel lines. So what they're called is alternate interior angles. 4 and 5 are alternate interior angles. 3 and 6 are to the opposite sides of the transversal. Okay? 3 and 6 are to the opposite sides of the transversal and inside the two parallel lines. So they are also alternate interior angles. Okay? Now, are 3 and 4 the same size? No. So 3 and 4 aren't alternate interior angles with each other. 3 is alternate interior with 6. 4 is alternate interior with 5. So that's corresponding angles, alternate interior angles. Let's look at 1 and 7. Are they on the same side of the transversal or alternate sides of the transversal? Alternate. Instead of lying to the inside in between, they're to the what of the parallel lines? Outside. So they're called alternate exterior angles. They're called alternate exterior angles. Besides 1 and 7 being alternate exterior angles, what's another pair of alternate exterior angles that you see up there, Ella? Besides 1 and 7, what else is alternate exterior? 2 and 8, exactly. 2 and 8. Okay. So, alternate exterior angles, they're going to be congruent to each other. Alternate interior angles, they're going to be congruent to each other. Corresponding angles, they're going to be congruent to each other, just like vertical angles are congruent to each other. Okay? So, when we have parallel lines, we have lots of different relationships. Here's another relationship that we're going to... Oh, let's just remember, let's just quiz you really quick on which angles are which. Okay? So, I'll go right here. I'll have it blown up so you guys can see. Corresponding angles. What angle is corresponding to angle number 1, Aiden? Same corresponding position with the transversal. Not 3. 1 and 3 are vertical angles. So, here's the parallel lines. Here's the transversal. They're in the same corresponding position. 5 is correct. Olivia, which one is corresponding with 2? Same corresponding position as 2. 6. Angle 3, Thomas, what's the same corresponding position as angle 3? 7. You are correct. And Amiria, what's the same corresponding as angle 4? 8. There we go. Those are corresponding angles. Alternate interior angles can only be to the inside. So we're talking about angles 1 and angles 4. And they're alternate interior with certain ones. Okay? So angle 1, what is it alternate interior with? Angle 1, Christian, what is the alternate interior with angle 1? Not 8. 8 is to the outside of the line, inside of the line, in between the lines. 7. Angle 1 and 7 are alternate interior because they're to the insides and then on the opposite side of the transversal. Nate, what's alternate interior with angle 4? 6. There we go. Alternate interior angles. Okay. Then we have alternate exterior angles. So angle 2 and angle 3 have alternate exterior angles. So what's alternate exterior with angle 2? Who should we pick on? Micah. 8. Angle 8. Okay. Then angle 3, Haley. What's angle 3 alternate exterior with?
1.
Not 1. 3 and 1 are vertical angles. They have to be to the outsides of the parallel lines. 5. There we go. Angle 5 is the alternate exterior. Okay? Notice how I put congruent symbols. 1 and 5 are corresponding. That makes them congruent. 2 and 6 are congruent. 3 and 7 are congruent. 4 and 8 are congruent. 1 and 7. So 1 is congruent to both 7 and 5. And what other one? 1 is congruent to 7, 5, and 3. Okay? Why is it congruent to 3? Because of vertical angles. Okay? Vertical angles. All right. Next thing that's happening. Okay? Besides congruent angles, we also have supplementary angles that we talk about in here. So, if two things are to the interior, inside of the two parallel lines, inside, and they're on the same side of the transversal, they're not congruent, but they're supplementary. What does supplementary mean, Mia? They add up to equal 180, exactly. They add up to equal 180. So, if they're same side interior angles, they add up to equal 180. If they're alternate interior, alternate exterior corresponding, they're equal to each other. But if they're same side interior, they add up to 180. Okay? So, X and 2, are they supplementary or are they congruent? Let's look at X and 2. Supplementary or congruent? What do you think, Ella? They're supplementary. And you can tell that because X is an acute angle. It's good looking. It's an acute angle. Yeah, you got my joke. It's really bad, horribly bad, but hey, it's math class, it's geometry, and I'm an old fart, so I can tell really bad jokes. All right, so X and 2 are supplementary. What about X and 7? Supplementary or congruent? Supplementary or congruent? They are congruent. What about X and 3? X and 3, Jillian. They are congruent. Why are they congruent?
Alternate interior.
Oh, you are wonderful. That is exactly why they're congruent, because they're alternate interior. Okay? So we got to get this down. What's going on between the angles? Okay? What about, come on, erase here. There we go. What about X and 8? What about X and 8? Illy. They're supplementary. Why are they supplementary? Because they are linear. They are a linear pair. Okay, they're a linear pair. So when they're on a straight line, they add up to 180. When they're in a straight line, they add up to 180. So if angle 3 is 55, how big is angle 1? How big is angle 1, Tate? Might need a calculator. Christian has one right on top of his computer there. 125. What's the measure of angle 2, Olivia? It is 55. Why? Okay, because it's supplementary to angle 1, according to Olivia, which works. It's also vertical with angle 3, which makes them congruent. That works. What's the measure of angle 4 equal to? What's the measure of angle 4? Thomas. 125. What's the measure of angle 5, Jordan? 125. What's the measure of angle 6, Ameria? 55. Very good. What's the measure of angle 7, Cambry? 55. And what's the measure of angle 8, Haley? 125. Okay. So we can figure out angle measures now with parallel lines. Okay. So just in review, this is a review. Alternate interior angles are congruent. Corresponding angles are congruent. Alternate exterior angles are congruent. All right. Here's a little proof that you might see for parallel lines. So we're given that M and N are parallel. So when they listed down the reasons, that is given to us. 1 and 3 are supplementary. Why are they supplementary? Well, because they're what types of angles? It says use same side interiors to show 1 is supplementary to 3, so they are same side interior angles. Okay? So since they're supplementary, supplementary means they add up to 180. That's the definition of supplementary angles. Then 2 and 3 have to be supplementary because they're on a straight line. So I would say that's a definition of a linear pair, personally, or the linear pairs theorem, I would say. But for them, they said the angle addition postulate. I don't like that. They're a linear pair. So, linear pair theorem. That's what I say. Okay? Now, see how this is equal to 180, this is equal to 180. So if we get rid of the 180s, they must be equal to each other. Okay? Substitution would work just fine for me. Also, what would work is a transitive property because the first equals second, second equals third, then first equals third. Okay? Then what did they do to both sides of this? They took away what? Measure of angle 3. When you take away, it's called subtraction. Okay? And equal angles are congruent angles by the definition of congruent angles. All right. So last thing here. I think nope, we got one more than this. Okay. Looking at this. This is parallel to this. And what we do with parallel lines, we make little arrows on them to say that they're parallel. Okay? This is parallel to this. These are parallel. And this here is parallel to this here, but that's not even going to figure in our reasoning too much. Okay? 68 and 1. What types of angles are 68 and 1 if they're smacked in between two parallel lines like that? What types of angles? What are the names of the special types of angles? What are they called, Tate? They're interior. What else are they? Are they alternate interior or same side interior? Same side interior because they're on the same side of this transversal. Here's our transversal. They're on the same side of it. What do we know about same side interior angles? Are they congruent or supplementary? Supplementary, 68 and 1. So if we take 180 minus 68, we get 112. All right. All right. 68 and angle 2 share a relationship. Okay. Here's the parallel lines. Here's the transversal. They're on the same side, but are they same side interior? No. Are they same side exterior? No. Okay? They're not same side interior, same side exterior, but we have a special name for these. It's one of those first three we talked about. What's the special name for that? Starts with a C. No. Corresponding. They are congruent, but they're called corresponding angles. So angle 2 equals 68. Now, is angle 3 68 just because 2 and 3 are corresponding? Yep, because what's parallel? These two are parallel, and here's the transversal. So they're corresponding, which makes angle 3 68. Okay? All right. Let's look at this picture. All right. Angles 1, 2, 3, 4, 5, and 6. Okay. Now, angle 1. We can figure out angle 1, and it doesn't have to be any of the four things that we associated with parallel lines here. How big is angle 1? Why is it 70 degrees, Tate? Yep, these are form a linear pair. Linear pairs always add up to 180, so this is 70. Whoa, lost it. Angle 2. How big is angle 2? 65, I hear. That is correct. Why is it 65? Because it's a linear pair with 115, and they add up to 180. When you have a straight line, they add up to 180. So that's 65. Angle 3. Why is it 65? 2 and 3 are corresponding. They're corresponding, so it makes them congruent. Okay. Angle 4. How big is angle 4? Why is it 115? Because it corresponds with the 115, or with angle 3, it forms a straight line. It's a linear pair, so they add up to 180. Okay? All right. Angle 5. What's angle 5 going to be equal to? 45. Why is it 45? Because it's corresponding with this one. Corresponding. And then angle 6. Also 45. Why? Vertical with the 45, or else alternate interior with angle 5. Okay? That's the types of problems you'll be doing. Plus, I need to clue you in about a couple special words. Now, this chapter, we're not going to do vocab. Okay? Because vocab is going to be so entrenched in these lessons. I'm not going to have a separate vocab sheet or a vocab quiz. The problem with that is there's no vocab sheet to turn in at test time, so you're not going to get extra credit on this test. No extra credit on this test, okay? But no vocab sheet or no vocab quizzes to fill out this chapter because, like I say, it's so entrenched in what we're doing. But a couple vocab words, okay? Parallel lines are coplanar. What do you think the word coplanar means? Because we've had the word collinear, which means the same line. What does coplanar mean, Thomas? Not the same slope, Jillian? No, that's not what we're looking for. We know parallel lines don't intersect, but I'm looking at what does the word coplanar mean? Illy, that means they're on the same plane. Now, skew lines are non-coplanar. So they're not on the same plane. So, what are skew lines? What are parallel lines? Look to the ceiling. Parallel lines. Okay? The metal strips in between the ceiling tiles, these are parallel, and we got some perpendicular ones going on up there too, but we got parallel ones. Okay? They are parallel. Ceiling and the floor. There are cracks between the floor tiles. The edges between the floor tiles are parallel with the ceiling lines too. Okay, they are parallel. But if you look at this ceiling line going this way and this crack between the edge between the line that it makes between the edges of the floor tiles, if these are going this way and this is going this way, they don't intersect, do they? But they're not parallel, so they're said to be skew because they're in two different planes, the floor and the ceiling, and they don't intersect, and they're not parallel. You can have, because what we can do is we can make a plane between this stripe up here and this stripe down here. We can make a plane, and then they'd be coplanar. Even though you say, well, the ceiling doesn't touch the floor, so they're not in the same plane. Well, we can make an imaginary plane that goes up and down between them, and then they can be parallel. But if you got one line going this way down in this plane and one line going this way in this plane, they're not going to be coplanar. So that's skew versus parallel. So you do have to know that this chapter, the difference between skew and parallel, that they really don't make obvious. And so these would be vocab words if we had vocab, but we're not doing vocab this chapter. So that's kind of things that you need to get in your mind. Okay? So let me put out the assignment. It is not super difficult, so we will put that out.